So anyway, yeah, I will just get started here. Hello, everybody. My name's Ian. I'm a volunteer here with the Mars Society, and happy to introduce this next presentation. And the title is A Potential Solution to Deal with Charged Particles on Mars. And this is given by Julia Alvarez Vallero. She is an Argentine electrical engineer, graduated at the top of her class. She received an award as the best GPA at the University of Cordoba, Argentina in 2020. She currently works as a power design engineer in INVAP, a world-class company in technological projects and the leader of development in Argentina. She has also worked as an analog designer in Folger Harpore Foundation. On the academic field, she has been an assistant teacher of physics at the University of Cordoba, Argentina. In 2022, she began a master's program in renewable energy, climate change, and sustainability, held by the University of Santiago de Compostela in Santiago de Compostela, Spain. So, Julia, yeah, you can take it away from here.
Well, hello. Good afternoon to everyone. I don't know if you are in Arizona or not. So good morning if it's a case of anyone. As Ian said, my name is Julia Alvarez Vallero. I am going to present a potential solution to deal with charged particles on Mars. Well, the schedule for this presentation will be as follows. First, I will make a small introduction of myself. I know that Ian have already presented, but I will do it. And then I will introduce the topics that I want to develop. I will present the problem. After that, what has been thought to solve this. I will give my proposal, then conclusions, the bibliography, and then questions. Well, some things about myself. Well, I am an electronic engineer from Argentina, and I am currently working in the aerospace sector, in the power subsystem, and I am now doing a master's degree in renewable energy. And well, I am curious in general, and I am kind of obsessed with space. So I was thinking how to introduce the topic that I would want to discuss. And for that, I would like to place you in a certain point of history. You know that from ancient times, humans have dreamed about what was in the sky, like what was above us. But when Gagarin finally reached the outer space, I think that from that moment, men and women realized that was possible, and they reach an objective and start wondering what was going to be the next challenge. And when Neil Armstrong, Edwin Aldrin, and Michael Collins arrived to the moon, the boundary of what was possible or not keep broadening. So people have to start thinking in a completely different way, because we have to start thinking how to solve problems on places we have never been. And Mars represents another challenge to overcome. And as you know, Earth is 59 million kilometers away from Mars, which represents 150 times the distance between Mars and the moon. So in order to design a mission to Mars, it is important to first see and explore without our eyes in order to reach and to assure the best possible mission conditions. So for that reason, we want to know the geological formation of the red planet and the different eras that it has been through. Especially one of the most important questions regarding Mars is whether human life is possible or not. So in this context, it is important to understand the environmental conditions of the space around Mars. As you know, the Earth has a permanent magnetic field that captures most of the charged particles that come from the sun or are generated by the solar wind and all the related phenomena. On the contrary, Mars does not have this permanent magnetic field, but it has an induced one generated by the combination of plasma around the planet and solar wind. We have two pictures here in the slide. The picture of the Earth. In the picture of the Earth, you can see the Van Allen belts, which shows the interaction between charged particles coming from the sun and the outer space and interacting with the magnetic field of planet Earth. Thanks to this, we are kind of safe here on Earth, but that this formation also represents a challenge for missions that want to go outside atmosphere or to deep space, because satellites satellites will have to deal with all this radiation, and humans that go into these into these missions will have to deal with the same amount of radiation that is there, and it's also in the whole universe. Thanks to MAVEN-1, a mission, the first current electric map of the Martian atmosphere was created. And with this information, it is possible to model the direction and the variation of the induced magnetic field on Earth and on Mars. I'm sorry. So here is a picture of of the induced current map in Mars. But the problem is that this induced magnetic field won't solve the problem of the charged particles. In space, we have three sources of radiation. We have SEPs, which are solar energetic particles. Then we have flares and coronal mass ejection. And finally, we have the galactic cosmic rays. So SEPs are generated during periods of high sun activity, and they occur from time to time, but have the power of damaging and modifying tissues and cells. This means that those are ionized radiation. This is ionized radiation. Prediction models of sun activity are being developed to know when it's more probable that SEPs particles will be generated. In the case of galactic cosmic rays, or GCR, are the slowly varying and highly energetic background sources of magnetic particles that constantly bombard Earth. GCR are originated outside the solar system and are likely formed by explosive events such as supernova. These highly energetic particles consist of essentially elements fully ionized, and because of this, these particles interact with and are influenced by magnetic fields. And finally, we have the flares and coronal mass ejection. The activity is continuous, but the effects are less evident due to the fact that near Earth, the magnetic field interacts with these particles, desviating them. But on Mars, all these radiation sources will be presented, and less external protection will be provided as a consequence of the lack of magnetic field. The possible ways to protect astronauts from this radiation that scientific community has been studying so far are these ones. First, different materials are being studied to produce better shielding. Then medical selection of radio-resistant astronauts. This means that from all the people that wanted to go to Mars, scientific will decide after certain tests which astronaut is more resistant to radiation, and they will select them. After that, they are proposing radioprotectors, which are kind of drugs that astronauts will have to drink or eat, and they are supposed to increase their radiation resistance. And then we have gene therapy and biomarkers. So biologists are studying which biomarkers made these radio-resistant astronauts what they are, and they want to improve these biomarkers in order to make astronauts more resistant to radiation. Then they are proposing hibernation during space exploration, and finally regeneration technology, which means that before leaving Earth, astronauts will have to, or scientists will have to take some tissue or cells from astronauts, and when they come back to Earth after Mars mission, if they have any damaged tissue or cell, after medical intervention, these tissue and cells will be changed. And here is my proposal. Many solutions have been proposed in order to protect astronauts from radiation. Nevertheless, the implementation of some of them is still under study, either for the lack of the right material or for the prevalence of one technique above the other one. It is clear that the best approximation to radiation shielding is a compound solution of the majority of the solutions that are being studied or even being proposed. The manufacturing of spacesuits with a Faraday cage on its external surface layer could reinforce the radiation shielding by retaining the charged particles in the external surface. An additional solution is the generation of a permanent magnetic field on the astronaut space, which is expected to protect them in case of high activity solar periods. I know that these have already been proposed, but the generation of a permanent magnetic field or in the whole planet, which is something difficult to reach, and also it will demand a lot of energy and a lot of years in order to generate this magnetic field. But thinking about creating a magnetic field into the astronaut space, it's not that weird or that crazy, and it have the two advantages. Let's say, as I mentioned before, scientists are making predictions of the solar activity, so they can predict when SEP's activity is going to happen. And because of that, you can think of a magnetic field that can be turned on or turned off when an alert it's turned on. And this will allow to reduce the power consumption into this astronaut space, which it's obviously not won't be that huge. And the addition of an external layer made of any conductive material may seem an irrational solution when thinking about communications, But rather than being a suppressor for communications, this outer layer could be redefined as a big ground plane, making use of it to increase the range of the small antennas placed on the astronaut suits. Although it is true that these solutions will solve the problem of the charged particles coming from the solar wind, they will not be able to address SEP's particle issues. For that reason, it is important to complement the external charge shielding with a thick layer of protective fabric. The need of a spacesuit repair to deal with charged particles is essential, and even when the solar activity is being monitored constantly and the SEPs have been studied to predict when will that come around, space agencies and private companies cannot rely on them. Astronaut lives are under their responsibility. To conclude, I would like to say that teamwork is essential, but teamwork between scientific designers, engineers, biologists, etc., to design the best suit solution to deal with charged particles, but to deal with all the environmental conditions that Mars have. It is essential that real like broader work team work together in order to reach this optimum design. And about my idea, well, I think that the idea of covering astronauts with cages may seem either simple or mad when thinking about communications between astronauts and their spacecraft. But the solution to this problem could be reached easily by changing like perspective. And another thing that I would like to say is that the solution might be in a new, innovative, and bold approach, or to come back to the simplest physics laws. Finally, I would like to close with this idea that we are always thinking how to solve problems with new technology. But sometimes I think that new technology might be the old technology. As you might know, if we think of the propulsion systems that are being used in the current satellites designed, we are start using as new technology whole thrusters, but these thrusters had been there for many years, and so that's my point. Thank you. Well, here is the bibliography that I consult, and I am open to your questions. And well, here is my contact if you want.
Oh yes, and if anyone has questions, yeah, you're welcome to speak up, or you could write it in the chat and I can read it out.
Oh, Julia, it seems that the present space suits are of quite old design. Have you seen quite a lot of new developments in your bibliography recently? Is there a lot of activity or very little activity?
What I have seen is that yes, there is a lot of activity within this topic, but I searched and I couldn't find a proposal of something like what I said, like a kind of Faraday's cage. What I'm thinking on is like a thin layer of any conductive material, and I haven't found that. Maybe they have some proposal, but I couldn't find it. But the truth is that they are working hard, and that there are many teams working on designing this.
Very good. Thank you.
You're welcome.
Okay, yeah, and I guess if nobody has any questions, I guess we could wrap this up. And to remind everyone, yeah, in about 10 minutes or so, the next workshops will be starting. And Julia, thank you again for coming here and giving this presentation.
Yes, thank you very much.
Thank you.